So this is what 1,000,000 iron ingots per hour looks like. But before we get there, let's start at the beginning. Iron farms are one of the most basic and essential farms in Minecraft. Almost everyone has made one, but have you ever wondered why there are so many different variations of iron farms and how much the design differences actually make a difference? Well, this was a series of questions I kept asking myself, so I decided to find out. I also wanted to push iron farms as far as possible and see if a 100% efficient farm was possible and how hard it would be to build. The results may surprise you as they did for me. In the end, this journey gave me a perspective and an understanding I did not have before making it, and I was hoping to share that with you. So my goal is that after this video, you will have a detailed insight into all aspects of designing an iron farm, understand the real game impact of design decisions, and can design your own high efficiency iron farms that fit any situation. And finally, we will have a bit of fun and push iron farming to the maximum. I would like to note here that I'm well aware that there are many more talented people than myself that have videos covering iron farm design. Even so, after researching this topic extensively, I still have more questions. And as a result, this video is aimed at an audience like, well, myself. My ambition is to answer all the questions and cover all the perspectives that I, myself, was wondering about, even after watching and reading the existing material. Okay, so with all of that out of the way, where do we start? Well, with the basics. So there are some rules behind all iron farms. There are two ways to spawn a golem, with villagers gossiping or villagers panicking. Gossiping is really only useful for peaceful mode, so we will skip that one completely as it is much slower than panic farms. With panic farms, you need 3 villagers. They need to have slept within the last 20 minutes and be panicking, i.e. scared by a zombie or other valid mob. Finally, they must not have detected an iron golem's presence or summoning within the last 600 game ticks or 30 seconds. After these conditions have been met, a villager can attempt to summon an iron golem, which then must have a valid spawn point to spawn. It's pretty straightforward, but there are some more details that we will get deeper into further along in the video. Even so, with these rules, we can calculate our maximum theoretical iron farm rate. A maximum of 1 iron golem can spawn every 30 seconds. There are 3,600 seconds in an hour. Divided by 30, that gives us 120 golems per hour. Golems drop 4 iron on average, so the theoretical maximum is 480 iron ingots per hour on average per villager cluster. To achieve this maximum rate, a couple of conditions must occur. Firstly, exactly 600 game ticks or 30 seconds after a villager has spawned a golem, the next golem must spawn. Secondly, immediately after the golem has spawned, it will poof, disappear. And finally, the villagers will be able to sleep, but they will sleep without disrupting the spawning cycle of 1 golem every 30 seconds. If all of these conditions are met, the maximum will theoretically be reached. But the big question now is how to achieve, or at least get as close as possible to all of these conditions. Alright, so I think perhaps the best way to talk about maximizing efficiency is to start with a, well, pretty inefficient farm, i.e. this one. It's a very simple farm, but not very efficient. At 317 ingots per hour, it's about 66% of the maximum. So let's improve it. But before we get started, I just want to note that there's nothing wrong with this farm or using this farm. We are trying to maximize efficiency in this video to learn about farm dynamic, not to tell anyone how to play the game. In almost all cases, a less than the most efficient farm is the best solution. Play as you would like and let others do the same. So, with that said, let's jump right into it. To increase this farm's efficiency, let's start off with the biggest bang for the buck, improving the time to kill. With this farm, we have quite a long time to kill. First the golem spawns, then it must be transported over to the lava, then it takes a full 12.5 seconds to kill the golem. The reason why this matters is because of the 4th spawn condition. The villager must not have detected an iron golem's presence or summoning within the last 30 seconds or 600 game ticks to summon a golem. Detecting a summoning is straightforward. When the golem is summoned by one of the villagers in the group, a cooldown countdown of 600 ticks starts for the entire group. But when talking about detecting the golem's presence, it's a little bit more complicated. Each villager scans a 33 by 32 by 33 area of blocks centered on its feet at a random time every 200 game ticks or 10 seconds. If during the scan a golem is detected, then the 600 tick cooldown timer is reset. This is demonstrated clearly with this farm here. Using Gnembon's carpet mod, we see the golem cooldown timer here. You see that all the villagers have different cooldown times? That's because of the iron golem detection. If it was due to summoning alone, the cooldowns would all be the same because they would be detecting the same summoning. But here they are different because they detect the golem after the summoning at random times for each individual villager. Alright, so let's dig into this with just a little bit of math. Using some geometry and basic assumptions, we can calculate that the iron golem will on average spawn roughly 2 blocks from the lava. Water pushes mobs at 1.4 meters per second, so we can round to roughly 1.5 seconds for the water to push the golem to the lava, and then an additional 12.5 seconds for the lava to kill the golem. That's roughly a 14-second kill time on average. What this results in is a high probability of resetting the golem spawn cooldown timer, but the real question is, by how much? Well, here is where another detail is important. The spawn attempt timer. We see here that there is a 100 tick countdown. This is a timer for spawn attempt. When it hits 0, the villager will attempt a summoning if all other conditions pass. What this means for our discussion is that the time between spawns will only increase in 100 tick or 5-second steps. Even if the golem detection only increases the cooldown timer, say like 2 seconds, the actual impact will be 5 seconds because of the spawn attempt timer. So what does this mean? Well, to simplify it, let's visualize it as a timeline. We can make it even easier by splitting this up into 5-second intervals to signify the spawn attempts. Any cooldown reset within these ranges will be rounded up to the next 5-second step. So remember, the villagers scan every 10 seconds. But at random times, which is assigned when the villagers are loaded. So for example, if the time happens to be at 8 seconds, then it will scan at 8 seconds and at 18. In this example, the villager will increase the cooldown time by 8 seconds and increase the time between spawns by 10 seconds due to the 5-second step. Now let's look at if the villager scan happens to align with 3 seconds. Then it will scan at 3 seconds and at 13 seconds. So in this case, the time between spawns will increase by 15 seconds because of that second scan at 13 seconds. So for our example, here are the zones that will increase our time between spawns by different amounts. The first 4 seconds increases the time between spawns by 15 seconds because of that second scan. The next 1 second increases the time by 5 seconds, and scans between 5 and 10 seconds increases the time by 10 seconds. So now we can calculate the expected impact on efficiency using probabilities. Remember, we must consider that there are 3 independent villagers. So the probability that at least one of the 3 villagers scans 4 seconds or before is about 78%. The probability that all 3 villagers scan between 4 and 5 seconds is about 0.1%. Or in this case, we're just going to round right to 0. The remainder of possibilities is then about 22% of the time. So 78% of the time, the timer will increase by 15 seconds. 22% of the time, the timer will increase by 10 seconds. We can then add these together to get the average time between spawns of about 14 seconds. This equates to approximately a 32% efficiency reduction, or from this factor alone, a farm efficiency of about 68%. That's not very good, but it is pretty close to our real game measured efficiency of 66%. The difference between our calculated efficiency of 68 and the in-game measured efficiency of 66 is due to other inefficiencies. What this clearly shows us is that the time to kill has a huge impact on overall farm efficiency. Hey, I just want to take a second to mention here, this video took quite a lot of effort. And as a small creator, any support you show is hugely motivating for me personally and highly appreciated. So if you want to support this video, please like and comment. If you want to support the channel, subscribe. And if you are interested in joining what I hope is a burgeoning community, check out the Discord. It right now literally has 5 people in it, so get in at the ground floor while you can. That said, thank you for the attention, now back to the video. But if we continue on this topic, then the question is, how do we reduce the time to kill? Well, kill is not really the right word. It's time to disappearance. Say we have that 33 by 32 by 33 box, and as long as we remove the golem from that box, then it won't be detected. So what is a good way to disappear the golem quickly? Well, gravity, for one. If the golem spawns on a platform 1 block above the villager's head, then it's a 19 block drop to the bottom of the detection range. And since golems are 2.7 blocks high, it's a 21.7 block drop out of the detection range. In Minecraft, that takes 1.3 seconds. Not too shabby. Unfortunately, we cannot just drop the golems directly. We need to spawn them on a platform and drop them off. Water is the most common way to do this. The downside is that water is quite slow compared to gravity, so the majority of the time to kill is actually with the water. If we have a one-directional platform 8 blocks long, then the approximate average distance to drop would be about 4.7 blocks. 4.7 divided by 1.4, it takes about 3.4 seconds to push the golem, plus drop time, 4.7 seconds. This equates to approximately an 85% chance of increasing the time between golems 5 seconds, resulting in a 12.4% efficiency reduction. That's not too bad, but the whole question behind this video is, can we do better? Well, there are 2 small improvements. First is to move the spawn platform to below the villagers. This results in about a 2% efficiency increase, so not a huge amount, but it is, well, something. The other improvement we can make is to reduce the water push distance by shortening our spawn platform. Here's a graph showing the efficiency reduction for different spawn platform lengths. You can see that the less distance the water has to push, the higher the efficiency of the farm. Makes sense, right? Well, it's wrong. Or well, not 100% wrong, but we're missing something important. When we decrease the length of the spawn platform, we then decrease the chances that an iron golem spawns at all. When a spawn attempt happens, the game selects a random column within the spawnable area to see if it's suitable to spawn. If so, it spawns a golem. If not, it tries again for a total of 10 attempts. So if we reduce the spawn platform size, then we increase the risk that all 10 attempts will fail, which has a significant impact on overall efficiency. Using this equation, we can plot the chance of spawn failures versus the number of blocks in the platform. We use a power of 30 rather than a power of 3 because all 3 villagers have 10 attempts. When we plot this as a graph, we see that at about 60 blocks, the chance of spawn failures is negligible. But below that, the impact can be quite significant. To demonstrate, let's try to modify our example farm. Its spawn platform is 5 blocks wide. If we make a water push distance 2 blocks long, then there are 10 potential spawnable blocks. And from the graph, that's about a 70% spawn success rate. This will decrease the farm's efficiency about 19% when considering spawn success probability and time to kill together. A reduction of 19% isn't too bad, but it is worse than our 8 block long farm, which had a reduction of 13.6% when also factoring in spawn success. So obviously we need to consider the amount of spawnable blocks, or it can have a significant impact. The easiest way to increase the amount of spawnable blocks without increasing the time to kill is to increase the width of the platform. The spawnable area is 16 by 16, so we can use up to a 16 block wide spawning platform. If we then add the impact of spawn success rate for different width platforms to our water push length graph, it looks something like this. So as long as the spawn platform has enough spawning spaces, i.e. is wide enough, the impact of spawn failures is not very noticeable. For example, our highest efficiency water push farm is a 16 wide, 2 long spawning platform below the villagers. This will work with a very good efficiency of 91.3%. Even so, I, for one, cannot love this farm design. Simply because, well, I'm paying, and it's kind of ugly. There is another problem though. When scaling up the farm, the golem detection areas between the villager pockets will overlap, meaning that the probability of reducing the golem spawn rates increases substantially. We can fix this out by spacing the farms out further, but then they become more difficult to build, and the collection system is going to be a little bit of a mess, and in the end, it's just simply not very elegant. So is there another option? Well, yes, but with a caveat: Nether Portals. When discussing time to kill, there is no faster way than Nether Portals. There are a couple of factors that make this work. First, iron golems have a 1.4 by 1.4 wide hitbox. Second, they spawn in the middle of the block. And third, they do not do block collision checks when they are looking for a spawnable location. All three of these together means that if a golem spawns on a block next to a portal, their hitbox will overlap with the portal and they will be instantly teleported to the nether. This allows us to achieve the time to kill condition for a max rate farm, well, pretty easily. We can space the portals 2 blocks apart and they will still work 100% of the time. As long as we maintain enough spawnable blocks, the spawn chance will be near 100% and our time to kill is next to 0. But I mentioned a caveat, and there is one, a big one. A setup like this has the potential to cause a bit of lag, particularly on servers. That said, this setup on a single player world with a decently modern computer like mine will be okay. So for the sake of good video structure, we will come back to the topic of lag later. First, I want to finish our discussion about designing a max rate farm. Here we have a very nice single unit farm. Time to kill is approximately 0, and we have plenty of spawning spaces, giving us a spawn success rate of 99.9999 and 10 more 9% success rate. On the nether side, we have a lava blade and some hoppers. So we should be set up for a max rate farm, right? Well, here is where most reasonable people will stop. With this farm, we will hit a 98 to 99% efficiency most of the time. So good enough. That though is not the point of this video. For this last 2% or so of efficiency optimizations, we need to look really deeply into our rules and see what's happening. In particular, these 2 rules. The first one we've covered extensively with time to kill. But the second one, we haven't really even mentioned. The villagers must be able to sleep, but that must not disrupt the spawning cycle. Meaning that the villagers need to sleep every 24,000 ticks or 20 minutes, but they need to do this while the golem cooldown timer is activated, not during spawn attempts. So now we are discussing our scare method. Here we have a very simple setup, a bouncing zombie. This is quite nice because there's no redstone. The whole idea is that the zombie most of the time has a line of sight with the villagers, i.e. is scaring them, but for a small amount of time the zombie breaks line of sight so the villagers can sleep. It's easy to see how this will cause inefficiencies. There's a small probability that the zombie will break line of sight at the same time as the spawn attempt. When this happens, it will skip that attempt and increase the time between golem spawns 5 seconds for that particular attempt. Again, we're talking pennies here. This is not a huge impact, but it is something. So can we do anything better? Well, yes. The obvious solution is using a redstone clock. Alright, let's pause here for a second. Here is where I need to note something. This video is made in 1.18.2, even though when it is being made, up through 1.19.2 has been released. The reason why is because of a bug that I found while making this video that increases the minimum time between spawns in the 1.19 versions. I made a video that explains this bug in detail, so check that out if you're curious. This change has no impact on the general concepts discussed earlier or further on, but would make the calculations and calculated efficiencies different. The reason I decided to use 1.18.2 here is because I believe that Mojang will patch this bug, so newer versions will likely match the timing discussed in this video. I may be wrong though, so make sure to verify the timing for whatever version you are working with. With that said, let's continue. The most common type of redstone clock is an etho hopper clock. This in theory will be better than the bouncing zombie chamber of death, but there is still a problem. This is such an incredibly tiny detail that it's almost unnoticeable, but I feel like I need to explain it regardless, and honestly, defend why. These details will have almost no impact on the farm, but I truly believe that understanding even these tiny little details will enrich overall understanding, so bear with me. Hopper clocks can only count at hopper speed, i.e. 4 redstone ticks or 8 game ticks an item. Our golem cooldown timer is 600 game ticks, i.e. 300 redstone ticks. So what we want to do is have the mob scaring half of the time and not scaring half of the time. This means scaring 150 redstone ticks and not scaring 150 redstone ticks. Here is our problem. 150 divided by 4 is 37.5 items in the hopper clock. There is no such thing as a half item. What this means is that we must use either 37 or 38. But either way, this causes the clock to be off by 4 redstone ticks a cycle. Those 4 redstone ticks add up every cycle until the clock offset is enough to miss a spawn attempt. I programmed a very simple Python program to simulate this, and the results show about a 98.4% total efficiency. Again, this literally reduces the efficiency 1.6%, so nothing to sweat about. Even so, at this point, my personal thought process was to try to develop a system which scares the villagers all the time and stop scaring the villagers for a short time during the night. The problem I ran into was that there was no way to consistently detect when it is night. The daylight detector is influenced by weather, and a redstone clock would work if no one slept, but anytime someone slept, it would totally mess up the clock and kill the farm completely. I will say, I believe there's a solution to the daylight sensor weather issue, which may be interesting to develop, so if anyone wants to take on the challenge, it would be a fun one. Even so, I gave up on that solution for the moment. But we do have another solution that is likely much simpler either way. We use a precise clock, i.e. a repeater clock. I looked up the name for this type, and I guess it's called a factorial stacking clock. But basically, we have a 25 tick clock here and a 6 tick clock here. They will not overlap until the 25 tick clock has run a total of 6 times. When they overlap, we'll switch the position of the piston. 25 times 6 is 150 ticks, so perfect. This farm gives us that perfect farm we are looking for, 100% efficiency. Now we have achieved what we set up for and covered all the fundamental topics of iron farms. Or, well, almost. We still have the portal lag discussion. This is an important one too, since there are a number of iron farm designs floating around which do not take this into consideration and can cause some grief for players, particularly if they play on a server. Now, I do not want to pretend like this is a topic I know a tremendous amount about, because I don't. But from what I understand, the lag is primarily due to loading the nether side of the portal link. Every time an entity enters a portal, the game must link and load the nether side. This process requires a fair amount of game resources. On a single player game like this one, the impact is not very noticeable for a farm of this size. When playing on a server though, it becomes more noticeable and has the potential to disrupt the entire server if unchecked. We can minimize the impact of this though with a small adjustment. Basically, nether portals have a property which allows the portal to stay loaded for 15 seconds or 300 game ticks after an entity has passed through it. If an additional entity passes through it, then it will extend this timer. So as long as we pass at least one entity through the portal more frequently than every 15 seconds, then the nether side will stay loaded and minimize lag. We can achieve this by having 3 separate farms which spawn golems offset by 10-second timers. This will give us a golem approximately every 10 seconds and keep the nether side loaded. I want to make clear, this will still act essentially as a chunk loader for the nether side of the farm, meaning that one player will be loading 2 dimensions, which is more resource intensive for the game, so it is not a lag-free option, but is much better than loading the dimension every 30 seconds. I cannot pretend to know the ins and outs of portal lag, but what I can do is test the different arrangements and show how they run on my computer. So we have 3 farms, an overworld only farm, a nether farm with the golem spawning all at the same time, i.e. the synced portal farm, which unloads and reloads the nether. Then finally a farm with golem spawning offset by 10 seconds. As you can see, we made each of these farms with pods of 4 villagers in each layer, and a pillager as a scare mob in the middle. So after testing these out, here are the performance numbers for all 3 farms. The numbers are in millisecond per tick. The lower the number, the less lag. We can see that as expected, the overworld only farm has the best performance and the synced portal farm has the worst. At this point, you may be thinking that the synced portal farm isn't too bad, since it only has a 30% higher millisecond per tick. That is misleading though. We're not seeing the whole picture. Now if we add the peak millisecond per tick to the graph, then we see another story completely. The peak for the overworld and the 10-second offset farms are nearly the same, but for the synced portal farm, the peak is much higher. So this shows that the portal farm must have an offset to prevent loading and unloading the nether, or they will cause a significant amount of lag every 30 seconds or so. Again, using a portal farm will still cause more lag than an overworld only farm, but at least with an offset is giving us the best performance possible and will significantly increase the efficiency of larger scale farms. So how far can we actually go with this? Well, let's push it a little bit. This is honestly where iron farming becomes kind of brain dead. If you have a single pod maximum efficiency farm, you get 480 ingots per hour. If you want a higher rate than that, you need to build more farms. You could go with a very simple farm like Ian X04's first day farm and build a ton of them, and it will give you a lot of iron. While I really like this design and am a big fan of what Ian X04 is doing, it's personally not my style. I would even say that for me, even our Lord and Savior Gnembon's iron farm doesn't fit my fancy. Not because it's bad, but because it's wide, and I prefer tall. I believe they're easier to make and fit into builds in industrial districts. But that's just my preference. So this is my preferred design. Note that it does not use the factorial stacking clock, because while that clock is fun, it kind of sucks in real game application. Instead, we use a 100 redstone tick repeater clock with a counting system I found by Mumbo Jumbo. This design is pretty cool, if I say so myself. Every time the clock pulses the counter, it switches the comparator output. The powered block then opens the trapdoor, and the scaffolding changes its appearance from ground supported to side supported scaffolding. This visual change is detectable through the entire scaffolding column with an observer, so we can effectively send the signal to the build limit vertically and take it off as many times as we would like. So the comparator switches down the line every 10 seconds, with each giving a 10-second pulse. Then we can build our platforms upward and just take an observer output, which one tick pulses the piston every state change. In this way, we can just alternate which scaffolding column we take from, and we will go up forever with good portal resetting. Here we have a full column from bedrock to build limit. This results in a little bit over 50,000 iron per hour. Surprisingly, this runs decently well. Of course, the milliseconds per tick is high, but that's just because we have so many entities. We can even double it, and it runs with 20 ticks per second with over 100,000 iron per hour, more than anyone would ever need. But what happens if we push it further? Well, here is 250,000 per hour. Now it's getting quite laggy as expected, but can we go further? What about 1 million? Can we do that? Well, yes, we can. So this is what 1 million iron ingots per hour looks like. Well, kind of, but not really. In theory, this is what it looks like, but we are removing the lag after the fact with replay mod. In reality, here we are, very laggy and frankly, unplayable. Even so, here it is, 1 million iron ingots per hour. It's understandable why it has such a huge impact on the game. It's not only the golems and the drops, but also the villagers and the pillagers, plus all the hoppers, the redstone, etc. It's not at all practical, at least with my computer. Now we are getting about 2 ticks per second, i.e. the game is just unplayable. But the point is that the concept is valid. After increasing efficiency, iron farms are just the jocks of farm. Build more, get more, simple as that. So while that was a bit of fun and proof of concept for something that is frankly absolutely pointless, there is a practical takeaway. That this farm, the 3 or more layer design, is valid as a concept, and a pretty decent max rate design. I have to admit, this farm, while good, is not flawless though. So max rate is not entirely accurate. The quote-unquote flaw is that there is a small chance that a villager pocket will detect another layer's golem's presence even though the death happens very quickly. If we say that the golem is there for 1 tick and a villager scans randomly every 200 ticks, then there is a 1 in 200 chance per villager. So the chances that at least one of the 12 villagers detects the layer below's golem spawn is about 5.8%. This is per layer, but does not include the bottom layer. So for a 3-layer farm, there is about a 99% efficiency, which goes down to about 98.6 when building an entire column. Due to this, it maybe isn't exactly a max rate farm, but close enough that I will continue to call it max rate and willingly spread that misinformation. If you really want a max rate farm, all you need to do is space out the layers more so that the layer below the villagers is not detectable. Even so, the more compact design will give you a very high rate that is more than enough for most players, and is expandable for those of you who want to go crazy with it. But Nico, you ask, what if I want my max rate farm without having to enslave so many villagers? Well, fair question. Here is my proposed design. A single zombie farm with 4 villager pockets. We use a simple repeater clock to make the travel and pause time to each villager cluster 300 divided by 4 or 75 redstone ticks. This means that our clock is perfectly aligned with the golem timer and allows us to spawn a golem exactly every 600 game ticks per villager cluster. Since we spawn the golems offset, we minimize lag the same as in our stacking farm. There is a very small likelihood of a villager detecting another cluster's golem, like we saw with the large scale farms, but this is very rare, and I never witnessed it. If it does happen, just reload the junk, and it will be fixed. This farm is, for all practical purposes, a max rate farm. So after that, I think we have finally covered everything. If you made it this far, you are an absolute rock star, and I really appreciate it. As mentioned before, this video took a lot of effort, so I really hope you enjoyed it. Thank you so much for watching, and goodbye.